Okay, so let's continue with the concrete structures. And me myself, I have been working for the few last years mainly with the concrete, and particularly with the precast concrete for the Scandinavian market. So I could talk also from precast perspective and what challenges do you have basically in Eurocode and in general in FEM softwares. And so, because actually most of the softwares deals very well with the cast in place concrete, and there is a fixed connections, but when it comes down to the precast concrete, where there is, for example, pinned connections between the walls and slabs, hollow core slabs, and in the longitudinal direction, you, for example, in case of hollow cores, need to make a release so that slab does not make any vertical load on the walls. So for some softwares, this is problematic. The RFEM deals great with that, and that's actually concerning general calculations. And then when it all is done, of course, there is also modules which helps to already calculate the reinforcement. So there is a separate modules for the surfaces like walls and slabs, and then there is for beams and columns, or you can use this column module also for the wall calculation. And in RFEM, this column calculation is based on one of the three methods described in Eurocode, particularly nominal curvature method. And then there is a module for pre-stored structures, not going deep in there. Actually, I guess this module has been developed by the same guys who is developing this idea software. So it's very similar in RFEM and idea. And regarding reinforcement calculations, there is always possibility to check existing situation when you give diameters of the rebars and spacing, and then do the checking for the ULS and SLS situations, or you can tell the software to find the most economical, by the weight, for example, solution. So let's talk a bit more about modeling. One very cool feature of the RFEM, which I'm, as a precast structure designer, I appreciate very much, which is called result beam. The idea behind it is, for example, you have building modeled of the surfaces. So of course you can calculate with the bended elements like slabs. It's more or less it's a clear situation. But then what to do with the walls? What to do with the lintels, for example, or wall itself as a compressed element. You cannot just calculate it as a bended element. To some extent, of course, you can, but with the precast concrete, where there is a pin connections on the top and on the bottom, so the main criteria will be buckling anyhow. So you must calculate that. So what to do with the wall where you have the surface and some concentration of stresses and on the corners. So how to deal with those? So this result beam lets you make like 1D element and tell the software that please integrate all the forces from the given width. Let's say it wall. So integrate all the forces from 1 meter to that one 1D element to the one line, so you have one line with the axial force, bending moment, shear forces, and then this 1D element you can run already and calculate it like a column, for example. Or you can as well divide like floor slab in those result beams and calculate then those result beams, for example, as hollow core slabs. All right, guess I will do a quick demo. So you're not seeing this, just a second. Let's do it. Probably would be great to have some help with that. I somehow cannot switch the screen. No one to help?
No, we in the bar.
Yeah, in the bar?
I will go to
to the bar? All right. Don't stay there. Come back.
say some joke.
When you will be leaving, then I will know. No, I guess I'm getting there. Right. So you see now. Not sure if it's getting recorded, but anyhow, we shall continue. So there is some small concrete building, and one more thing which I would like to mention regarding RFEMs, that it has a great meshing tool. The meshing is really good. You very rarely get any problems with the mesh when it cannot create or something like that, which is very often the case with the other softwares. So let's design some element. As I was telling about this result beam, you can choose the type of the element result beam, define that you want, for example, integrate the forces, for example, from this kind of width. You can say that you want to take those forces, for example, only from this wall, right? It's already designed, but you can change the cross section. So, and this result beam doesn't give any stiffness or weight to the structure. It's just like imaginary element, just to integrate the forces. All right, let's make a lintel of that. All right, so then we have this lintel, which is 1D element. We can now go, for example, to the module meant for the beams. So here, yes, there is also the Lithuanian code. Just tell that we want to calculate ULS and let's add some for the SLS. And there is also a possibility to calculate fire resistance. Do not have at the moment any load case for that. Okay, just add something. Okay, then you can tell the software to want to choose between example, this diameter of reinforcement and this, and software will find most economical solution for that. Same regarding stirrups. Okay, there you are defining concrete covers, so you can define by yourself, or there is a possibility to automatically just giving the exposure class, other parameters, the lifetime of the building, or could be the foundation, take into account that, right? Okay, you can define minimal reinforcement by yourself or let the software decide. Okay, this one comes from the national annexes. And then also all the parameters regarding serviceability. Instead, you can define by yourself the limit of the cracks, or you can let the software calculate that. Some information regarding that. Okay, and also some parameters regarding fire resistance. You can change the minutes which structure should withstand, and add the fire load to only some of the sites or all of the sites of the structure. So when all is said and done, I will not run for all the elements, just for this one. Alright, now it has been calculated. You can see all the results, the internal forces that has been used in this calculation, the stresses in the concrete and in the steel. And then we can go to the reinforcement. It's in 3D, so it takes into account as well the results from the ULS and SLS, but also it takes into account minimal requirements by the Eurocode. Same regarding shear reinforcement. Then you go to the serviceability check. So you can see the stress in the steel. You can see cracking, so it's not cracking very much, which you can expect, I guess, from that lintel. So, and then there is a design ratio. So you can always, as I said before, so this is chosen by the software, but you can here change the diameters or number of the bars and recalculate on existing situation. Closer look. Okay, and then there is also some small schedule. So you can make multiple instances of this calculation for different reinforcement type, and then quickly switch between those and compare for example, the total mass of the reinforcement. All right, so let's do similar for the column. Also, we'll use the result beam. Just let's modify the parameters. Surface the same. actually, I have been doing this, and this is great. Just all the precast building, all the walls can be divided in such small pieces, and then you have very good result to show someone. There is no question why there is reinforcement like that. For example, when on the corner it shows 10 times more, for example. Those are very, very clear results that you can prove. Okay, let's go to the column module. Let's choose the column. It's Latvian code, but I guess it must be Lithuanian. Yes. I don't know why, but for Latvia there is only some national annexes. For Lithuania, I guess there is all. You are lucky. I don't know why. So let's also for the column, the fire resistance might be very important in most cases. So, and the same with the reinforcement, you can tell that you want to choose between these diameters like that. And the links. So, same regarding the concrete cover. Right. Fire resistance. Let's add to all the surfaces. And here you can modify the effective length of the column. It's actually taking that automatically. You can change. You can see it's 0.5 or something, but because it's near to this shear wall, so Eurocode allows you to reduce the effective length of the elements walls that are braced by the shear walls. Okay, let's run the calculation. So immediately you get the design ratio. You get all the coefficients and checks that has been done. And you can go to the reinforcement, take a look in 3D. As well the schedule. So it's pretty easy and straightforward. All right, and then probably the last section in my presentation, it would be for the slabs, for the punching. So as you know, there is this one is pretty much different from as it was in SNPs, this calculation method, and usually in the Eurocode you get more this reinforcement, shear reinforcement. And there's an interesting situation till the one point you don't need at all, and when you need much of those. So it's a bit different that it was in SNP. And the calculation is more sophisticated also. So let's see how the RFEM deals with that. It's a concrete punch. Right, I'm not gonna do it for all. Let's take some near this opening. One more. right, during the load. You can do some adjustments here, define also the longitudinal reinforcement. As you know, in your code, it takes into account when calculating the punching reinforcement, takes account also the bending reinforcement. Or you can add some additional openings. So, but it recognizes from the model where it's located, it knows that there is a opening beside, so it will take that account that it cannot create the full circle around the column. Okay. Okay, it's too fast. Okay, so here you can see the results. It's for this one column. There is no need for the shear reinforcement at all. For the other one, this one number shows that without the shear reinforcement, the concrete is used by 127%. So basically, it fails. There needs to be shear reinforcement. There you can also see all the coefficients. You can modify the ratios of the flexural reinforcement. Basically, this module, if there has been slab has been calculated, so it will take those values of the reinforcement and feed in this module. Or you can add that manually. There you can see the control parameters. All right, and concrete capacities without the reinforcement. So and then we can go to the reinforcement. As I said, there you don't need any. And on the second one near the opening, you need some shear reinforcement, and it should be divided into perimeters. And there is also information how you should put those links or whatever. There is a tangential spacing of shear links, diameter, and the number of the shear links that you need. So I guess anyone who has been calculating the punching will appreciate that it's quite simple and straightforward. All right. So do I have some time? No. Okay, just show some more. There is a external module which is for the pre-stressed concrete, and as I said, this might be pretty similar what the idea has.
Sorry, Jānis, it's the same.
It's the same.
It's the
is
idea
even
statica prepared with models to RFEM.
Okay, so this is the same then.
Yes, additional model.
That's good, and then you have this module for the shapes. If you have hollow core slabs or some I-beams, you can design those in this module. It's quite simple. If you get the, for example, hollow core profile in DVG format from the factory, you just feed that in, and you get the new profile, which you can use in an RFEM. So that would be it for me today. Thank you very much for your attention.